will be doing a review too, and our title is non-English review for predicting the heart blockage and testing So team members are Hari, myself Rohit, and Vayu and Rishi. So these are the contents. First we will introduce the introduction. Next. So the problem definition. So we all know cardiovascular diseases continue to be among the topmost leading causes of death in global. So intervention diagnostic techniques for detecting artery blockage often are invasive, time-consuming, and resource-intensive procedures. What are the challenges we have to do? Extracting meaningful features from complex heart-related signals, ensuring adequate dataset quality, balance and mass spectrum, achieving predictive reliability, comparable, and clinical diagnostic standards. So what are our objectives? Our objective is to design a CNN-based predictive framework capable for analyzing the biosignal patterns with the heart blockages. We are implement this robust pre-processing pipeline that enhances signal quality and improves model interpretation. We also can evaluate the performance of the CNN model using standard metrics, which are used to redefine the architecture based on the observed outcomes through the inputs. We also plan to establish an end-to-end phased implementation, compromising data preparation model, training and performance visualization. The review work will be continued by the Rishi.
Thank you, Rohit. Now coming to the review and summary. So what we did in the first page is just an overview of what the idea is and what problem we are going to solve the problem. And the problem is that there is a non-invasive method for predicting an heart blockage of a person. So we are going to achieve that by using CNN and machine learning model. The machine learning model itself. Then we conducted a literature survey and identified the essential art sounds which are important for our model. Then defined the need for non-invasive, affordable. It's a very important affordable machine learning based model. And then there comes the finalized form statement and selected the CNN out of all the things. We even gone through with LSTM, but in that we got less accuracy. But in CNN we got more accuracy, which will be explained further. Design the initial workflow, how we are going to collect the data and how we are going to train it, and identify necessary tools and technologies which are needed for our next. Then comes the system design. The system design is like this: a patient, a user comes, then through microphone or a digital oscilloscope you will get the sound. Then the signal acoustication model is nothing but just going to amplify or get the sound waves which are from the heart. Then processing and de-noising means just removing the errors which we get through that. Then comes the segmentation, that is S1 and S2 nothing but loved up sounds. Then comes the MEL spectrogram feature extraction. In that we are going to convert the sound into image. Then from there we are going to extract the features what they are. Then CNN based classification, based on the extracted or generated image, it going to classify to which disease it belongs to or whether the person is normal or not. Then comes the prediction output, then an outer report. Then implementation details. So these are the technologies and tools which we are going to use. Of course, we are going to use Python. It's a core language for us. Then comes the Librosa, extracts MFCC, which we have read MEL spectrogram, the extraction feature of that. Then comes R-Tweak feature from audio recording. To that. Then compare and pandas, we know these are the standard for graphs and calculation based libraries. Then TensorFlow layers and Matplotlib, Google Colab, where we are going to put all the code and we are going to run. Then comes digital oscilloscope and the flash for website animation.
What is
MEL feature
MEL frequency.
MEL frequency.
Caption MEL frequency.
It's just going to capture the frequency of the sound. Then further part will be
So coming to the code pipeline and overview, firstly we will be loading and pre-processing the data. Like the data might be containing some of the
the errors, and some of the noise will be doing the pre-processing here. Secondly, we will be converting it into spectrogram images. The sound will be converted into Bell spectrogram images.
It is that much important to convert the sound to the image.
Yeah.
Yes, ma'am. Because we are using CNN model itself finally to detect whether heart is blocked or not.
We
Because
can collect the data, right?
We can collect.
Instead of images, I can get the axis, x-axis and y-axis of that data.
that Bell spectrogram image refers to that itself, ma'am. We are plotting the frequency sound in the X and Y graph. That's all. But it will be in the form of image, so that we will be feeding that image to CNN.
But we need some strategies. A bit.
Why we use spectrographics? It is for visual.
Vision exercise.
That's it.
What is generating? So we are using CNN.
Next level is the difference why we use spectrogram. So CNN, as I said, is converted spectrogram images will be fed to CNN and LSTM. As of our research, the LSTM is not giving that much accuracy, so we are dropping the LSTM. We are going with the CNN, and the classification will be saying whether heart is blocked. Next question. Ma'am, I'll run the code and I'll show why, how we are converting the sound into spectrogram and why we choose that method to do it.
Cable touch power.
Tricuspid wall. It is tricuspid wall block.
Observer is going fast beta.
Come back to the
Normally 2 bits is 3 to 4 bits. It will supply small features in instruction. Frequency varies.
So first sound, when I played first sound, it was the normal sound, it was lambda, and the output was like this. When we converted it into Bell spectrogram image, the output was like this. But when we do the sound of Bell spectrogram image of tricuspid wall block, so the sound was like this. So now we can easily classify the image here, right? The sound is highly frequency at 16,000, and here it is very low frequency. So this is the main feature, main key primary what we are using to detect the heart block. So the output will be like this one. If the heart is blocked or if it is having any other diseases regurgitation, it will be showing 1. And the probability, how much the probability our model has identified, whether comparing to the training data, will be showing it has identified 90%, 90%. And this is the methodology what we are trying to keep on. So the next part will be extended.
Here I am going to explain about the problem and the solution. Data investment. Here we use hard data. Hard data consists of normal and abnormal. Normal means the person do not have heart disease. Abnormal means the person have heart disease. Compared to abnormal, we have more normal data. for solving this problem, we use solution called class balancing and augmentation. Here, normal data is normal, so we modify the existing data by changing the features like increasing the tone and changing the frequency and create the own abnormal data. So we balance the data. Next is high frequency noise. High frequency noise means the data may consist of noise, device noise and breathing noise, which we are not needed for this. So for that, solution is noise reduction and normalization. Here we normalize this one. We remove all the noises which are not wanted for the fitting. Next is overfitting. Overfitting is the model is well trained with trained data set, but does not work on new data set or existing data set. So for this, we use dropout and regularization. Here, ma'am, for example, we take 1000 set of neurons in CNN. 800 sets of dropout. Here we ignore some neurons, so that the neuron focus on some does not focus on some specific features. Dropout means ignoring some neurons in the data set, because some data set focus on only some individual features. Next is the hyperparameter sensitivity. Our model performance can be measured by parameters such as layers, filter layer, CNN layer, on dropout layer. So the parameters, here we tune the parameters, so we get the correct expanding the data set by collecting the data set from various sources like patients and different heart diseases. Next, integrating real-time data collection. Integrating real-time data collection using open sensor devices, so we can get more data. Improving the CNN model architecture to deeper and more accurate feature extraction. Apply advanced smart reduction technology to generate a clear structure. Here is CNN Python library converts the art sound into spectrographic values. So here we can use advanced technology, noise reduction technology. Next, phase 3 we develop a simple user interaction. For real-time prediction, we use for testing our model in real. Deploying the trained model and performing end-to-end system testing.
Is it implemented in phase 3 or future one?
Phase 3
Real time.
Yes, ma'am. Real time.
Devices and the sensors.
What?
Big sensors, acoustic sensors and ಆಮೇಲೆ ಇನ್ನೊಂದು ಆರ್ಟ್ ಸೌಂಡ್ ಕಲೆಕ್ಟ್ ಮಾಡೋಕ್ಕೆ ಒಂದು
But in phase 3,
ಗೊತ್ತಿಲ್ಲ
phase 3 ನಾವು
Performance using additional metrics like precision, recall and accuracy. Lastly, preparing the report and demonstration. Learning of here we learn how we use CNN and CNN, how to create a spectrogram generation of art sound. Next, development and implementing CNN based model. Here we developed a CNN based model which can predict an heart blockage without invasive method. Strengthen skills in tensor flow and data processing and model optimization. Enhance the teamwork ability, presenting skill and overall project management. Gain an understanding of AI ethics, data handling, and real world applications.
Coming to the conclusion, as we said, we will be collecting. This is the model which helps all the patients.
which is non-invasive, will be not injecting anything to body, directly will be saying whether heart is blocked or not. And it is, as I said, it is a CNN based model. And the process, what we are going through is we are collecting data, we are pre-processing, we are filtering the data, we are removing the noises, and we are converting the sound into spectrogram images, and we will be training those images to our model, and finally we will be evaluating the outputs. So the promising results, what we are planning to do is, the CNN should be able to classify all the 5 different types of heart diseases. It should be able to identify the sound which belongs to which heart disease. And the main challenge, as Hari discussed, that is data balancing. We have the data of we have normal heart sound data, but we have lack of the sounds which are having the heart diseases. So we are trying to fill that, and the noise reduction and model optimization. So coming to this phase 2 it marks a significant progress. In phase 3, as we said, we will be developing a user interface, and we will be finally validating which sound belongs to what type of heart disease. So this was all.